Hello everyone, welcome to my channel GVS Chem. In this video, I am going to explain some numericals based on different formulae in electrochemistry chapter. Please subscribe to my channel, like, share and comment my videos.
Now the problem is the standard Gibbs energy, that is delta R G naught, for the reaction is the reaction is given here is minus 300 kilojoule per mole. The reaction is zinc solid plus 2 Ag plus gives zinc 2 plus in aqueous plus 2 Ag solid. Calculate E naught cell for the reaction provided 1 Faraday equal to 96,500 coulombs per mole. Now we know that standard Gibbs energy delta R G naught equal to minus NF E naught cell, minus NF E naught cell. Now in the reaction 2 electrons are involved. See here zinc becomes zinc 2 plus, that means 2 electrons are released and these 2 electrons are taken by silver to become silver solid. Therefore number of electrons equal to number of electrons involved, N equal to 2. F is the Faraday constant. Faraday constant. What is the Faraday constant given here? 96,500 coulombs per mole. Right. Now we have to find the E naught cell. What is delta R Z naught equal to minus 300 kilojoule per mole. This is given in kilojoule. Therefore convert this into the joule. 1 kilojoule equal to 1000 joules. Therefore this is nothing but 300,000 joules per mole. Now substitute these values in this reaction. Therefore minus 3 lakh kilojoule per mole is equal to minus N is 2, F is 96,500 into E naught cell. So minus get cancelled on either side, and here this is minus 3 lakh kilo, this is joule, this is only joule per mole equal to 2 into 965, this is nothing but 0, 13, 19 into E naught cell. So 3 zeros get cancelled. E naught cell equal to 300, minus get cancelled, therefore this becomes plus 300 by 193. This is approximately this is a 1.55 volt. So approximately this value is 1.55 volt. Based on this Gibbs free energy, relation between Gibbs energy and the E naught cell, let us do one more problem. So the problem is calculate delta R G naught for the following reaction. The reaction is nickel solid plus 2 Ag plus aqueous gives nickel 2 plus aqueous plus 2 Ag plus solid. Given E naught cell equal to 1.05 V and Faraday constant 1 Faraday equal to 96,500 coulomb per mole. Now the problem is calculate delta R G naught for the reaction nickel solid plus 2 Ag plus in aqueous solution gives nickel 2 plus in aqueous solution plus 2 Ag solid. This is solid. Given E naught cell equal to 1.05 volt and 1 Faraday equal to 96,500 coulomb per mole. Now the formula here is, what is the formula we have to use? Formula used equal to delta R G naught equal to minus NF E naught cell. Minus NF E naught cell. So what is the number of electrons involved? Number of electrons involved equal to nickel solid becomes nickel 2 plus. Therefore, 2 electrons are released and the released electrons are taken by 2 silver ions to become silver solid. Therefore, number of electrons involved is 2. Now, Faraday constant. Faraday constant F equal to 96,500 coulomb per mole. Right. E naught cell equal to how much? 1.05 volt. 1.05 volt. So substitute these values here. Delta R G naught equal to minus 2 into 96,500 into 1.05. This is minus 1930. 1,93,000 into 1.05. If we multiply this, we get minus 202650. 202650. What is this? Joule per mole. So if we divide this with 1000, minus 202.65 kilojoule per mole. So this is the standard Gibbs energy for this reaction. Now in this problem, let us find equilibrium constant also. So the equilibrium constant NF E naught cell equal to RT ln Kc. Kc is the equilibrium constant. So this is NF E naught cell equal to ln. Natural logarithm can be replaced by multiplying with 2.303 RT log Kc. So log Kc equal to NF E naught cell by 2.303 RT, where R is a gas constant, T is a temperature. Temperature is 25 degrees centigrade, that is 298 K. Now we got this value NF E naught cell. How much we got? 2.202650. This is joule per mole by 2.303 into R value 8.314 joule per mole K minus 1 into temperature 298 K. So here K get cancelled, mole get cancelled, finally joule get cancelled. So what is left here? The value is log Kc equal to 35.516. So to get Kc, we have to find Kc equal to anti-log of 35.516. So in this number, this is the characteristic and this is the mantissa. We have to see the logarithm for this mantissa only. Therefore, Kc equal to, for this anti-logarithm is 3.281 into, this becomes 10 to the power, 10 power, this 35 becomes 10 power. Therefore, Kc equal to 3.281 into 10 to the power 35. As Kc value is very high, this indicates that the reaction is almost complete. Reaction is almost complete. Now let us do one more problem. Calculate the EMF of the cell at cell 298 Kelvin. The cell given here is Fe solid, Fe2 plus, and the concentration of ferrous ions is 0.001 m. Salt bridge. Concentration of H plus ion is 0.01 oblique hydrogen gas. First of all, let us write the cell reactions. So, oxidation of cell is Fe becomes Fe2 plus, it releases 2 electrons. This is oxidation of cell. On the other hand, reduction of cell is H plus, gives 2H plus and of course it takes 2 electrons and become H2 gas. H2 gas. Now add these two reactions, therefore we get Fe plus 2H plus gives Fe2 plus H2 gas. Now how many electrons are involved? 2 electrons are involved. The cell reaction here, E0 cell equal to plus 0.44. E0 cell is plus 0.44. Now Nernst equation is E cell equal to E0 cell minus RT by NF ln oxidized state by reduced state. Oxidized state by reduced state. Therefore, this becomes E cell equal to E0 cell. How much is given? Plus 0.44 V minus. If we calculate all this, we get 0.059 by N, where N is the number of electrons, log Fe 2 plus by H plus concentration. H plus 2H plus is there, therefore this becomes a square. Now this is 0.044 minus 0.059 by number of electrons 2 log concentration of ferrous ion is 0.001 by concentration of hydrogen ion is 0.01 square. Right. Therefore this becomes plus 0.44 minus 0.059 by 2 becomes 0.0295 log. I shall write log here, log. This becomes 0.001 by 0.01 whole square becomes 0.0001. Right. Therefore this becomes plus 0.44 minus 0.0295 log how much this is? 1 by 0.1. 1 by 0.1. So this 1 by 0.1 becomes 10. So plus 0.44 minus 0.0295 log 10. What is the value of log 10? Log 10 is 1. Therefore plus 0.44 minus 0.0295 into 1. This becomes plus 0.44 minus 0.0295. So if we subtract this, so this becomes 0.4105 V. 0.4105. So this is the EMF of the cell. This is the EMF of this given cell. Now let us do one more problem. Calculate EMF of the cell. Zinc solid oblique zinc 2 plus concentration is 0.01 m. Salt bridge Az plus concentration is 0.001 m oblique Az solid. Given the E0 cell is 1.56 volt. So the Nernst equation is, now first of all let us write the equation for the reaction. So oxidation of cell is zinc solid gives zinc 2 plus 2 electrons. Similarly, reduction of cell is silver plus gives silver. So here 2 silver ions takes 2 electrons and become 2 AC. Now if we add both of these, we get the cell reaction. Therefore cell reaction is zinc plus 2 Az gives zinc 2 plus 2 Az. Now how many electrons are involved? Number of electrons involved is 2. Therefore number of electrons involved N equal to 2. Right. Now Nernst equation E cell equal to E0 cell minus 0.059 by n. Minus, see this minus 0.059 by n we get from minus RT by NF Ln, oxidized state by reduced state. Here the oxidized state is zinc 2 plus by Az plus. How many? 2 in the stoichiometric reaction, it is coefficient is 2, therefore it comes as power 2. Right. Now what is E naught cell given? E naught cell given here is 1.56 minus 0.059 by 2 log concentration of zinc is 0.01 by concentration of silver ion is 0.001 whole square. So this becomes how much this is? This becomes equal to 1.56 minus 0.059 by 2 becomes 0.0295 log, this is 0.01 by 0.501, because whole square 0.001 whole square becomes 0.501. This becomes 1.56 minus 0.0295 log. So how much this becomes? This is 10,000. 10,000. So here 0.01 by 0.501 becomes 10,000. This is 1.56 minus 0.0295 log 10,000 can be written as 10 to the power 4. So this coefficient, power of log power can be brought as coefficient. Therefore this is 1.56 minus 0.0295 into 4 log 10. We know that log 10 is 1. Therefore this becomes 1.56 minus 0.0295 into 4. This becomes 1.56 minus 4 5s 20, 36, 38, 8, 11. So before 4 zeros. So this is now how much this is? So if we subtract this we get 1.4420 volt. So this is the E naught E cell, electromotive force of the cell under these concentrations. Now let us see one more problem. Write the Nernst equation for the cell. Zinc solid plus Cu2 plus aqueous gives zinc 2 plus aqueous plus Cu solid. How will the E cell be affected when the concentration of Cu2 plus ions increased and Zn2 plus ions increased? Right. First of all, let us write the Nernst equation. So for the Nernst equation, E cell equal to E naught cell minus RT by NF Ln oxidized state by reduced state, oxidized state by reduced state. So this is E cell equal to E naught cell minus 0.059 by n log. Here what is the oxidized state? Zinc 2 plus ions by Cu2 plus ions. Here concentration of metals we are not taking, because by the convention concentration of metal is taken as a unity. Now these questions, if Cu2 plus ion, see Cu2 plus ions are in cathodic cell, cathodic half cell. If Cu2 plus ions increase, then what happens? E cell increases. If Cu2 plus ions, that is ions in the cathodic half cell increases, E cell increases. On the other hand, zinc 2 plus ions are in anodic half cell. If ions in anodic half cell increases, then E cell decreases. Now let us do one more problem. Calculate the lambda m naught for magnesium chloride. Lambda m naught means limiting molar conductivity or molar conductivity at infinite dilution. If lambda naught values for magnesium 2 plus and Cl minus ions are 106 Siemens centimeter square mole minus 1 and 76.3 Siemens centimeter square mole minus 1 respectively. Now here, according to Kohlrausch law states that the limiting molar conductivity of an electrolyte is nothing but the sum of the limiting molar conductivities of individual ions, irrespective of the ions associate with each other. Therefore, as per Kohlrausch law of independent migration of ions, lambda m naught for magnesium chloride is equal to lambda m naught for magnesium 2 plus lambda m naught for Cl minus. See here, chloride ion, in magnesium chloride there are 2 chloride ions, therefore this becomes 2. So this is, just substitute these values here. For magnesium ion this is 106 plus 2 into chloride ion 76.3. Therefore 106 plus 6, 12, 15. So if you add this 8, 5, 258.6 Siemens centimeter square mole minus 1. So this is the limiting molar conductivity of magnesium chloride. Now let us do one more problem. Calculate the potential of hydrogen electrode when it is in contact with the solution whose pH is 10. Now what is pH? pH equal to minus log H plus ion concentration. So pH is 10 here. So minus log H plus equal to 10, or otherwise log H plus is equal to 10. Now the cell reaction is H plus 2H plus 2 electrons give H2. Now Nernst equation is E cell equal to E naught cell minus 0.059 by n. So this is log H2 by H plus taken square. Now H2, since H2 is gas, its concentration is taken as 1. Since hydrogen is gas, concentration is taken as 1. Now, what is the electrode potential of hydrogen? Standard electrode potential of hydrogen is 0. Therefore, E cell equal to 0 minus 0.059 by n is 2 electrons log 1 by, because hydrogen concentration, gas concentration is 1, by H plus square. So this can be written as E cell equal to 0 minus 0.0295 log. So here in denominator H plus can be written as a numerator. Therefore this becomes H plus to the power minus 2. So this is nothing but 0.02 minus 0.0295 into minus 2 log H plus ion concentration. This is minus of minus plus 0.059 log H plus how much? Minus 10. Therefore this is nothing but minus 0.590. So this is the electrode potential of hydrogen whose pH is 10. Now let us do one more problem. Now let us do another problem. Molar conductivity of 0.05 m methanoic acid is 46.1 Siemens centimeter square mole minus 1. Calculate its degree of dissociation. Calculate the degree of dissociation and dissociation constant given that lambda m naught that is limiting molar conductivity of hydrogen ion is 349.6 Siemens centimeter square mole minus 1, and methanoate ion is 54.6 Siemens centimeter square mole minus 1. Now, first of all, as limiting molar conductivities of individual ions are given, find the limiting molar conductivity of methanoic acid HCOOH is equal to lambda m naught H plus lambda m naught HCOO minus. So this is nothing but 349.6 plus 54.6. So this is 12, 14, 10, 404.2 Siemens centimeter square mole minus 1. Now, degree of dissociation alpha equal to lambda m by lambda m naught. Lambda m by lambda m naught. So, what is lambda m? Lambda m is 46.1 by 404.2. So, if we calculate this, we get 0.114. 0.114. This is the degree of dissociation. Now, dissociation constant. Dissociation constant K equal to C alpha square by 1 minus alpha. C alpha square by 1 minus alpha. What is alpha degree of dissociation? Just now we calculated. What is C concentration? So what is the concentration here? 0.025 into 0.114 into 0.114 by 1 minus 0.114. So if we calculate this value becomes 0.00285 by, and this value becomes 0.886. So this becomes 0.000366. So this is the degree of dissociation. So how can we write this? This we can write it as 3.66 into 10 to the power minus 4. So this is the degree of dissociation. So in this way we can find we can do some numericals which are, and of course these numericals, doing these numericals applying different formulae in this electrochemistry chapter is very important, and prepare for board examinations well.